The function g is defined and differentiable on the closed interval from -7 to 5 and satisfies g of 0 equals 5. So that's our starting point. The graph of g prime consists of a semicircle and 3-line segments. That's what's given to the right here. Okay, so it's differentiable, meaning that g is differentiable, meaning that g prime is defined for all values of x in that interval, and that's true here, so it's continuous. And we're asked to find the g value at x equals 3. Okay, so again, we want to find the g value at 3. That's going to be based on the starting position of y equals 5 plus the area underneath the curve of the derivative, g prime in this case, which was given to us to the right, the area starting from 0 all the way to x is 3. And that's going to be under g prime, and we'll do this as t dt. So g of 3 is equal to 5 plus the area from 0 to 3. Okay, so if I take a look at the area from 0 to 3, I'm just going to shape that in. 0 to 3, okay, so that's 0 to 2, and that's going to be a quarter circle, so we're going to do pi r squared, so 4 pi, and we're going to divide it into 4s because it's only a quarter circle, so that ends up being 4 pi divided by 4, which is just pi. We also have this area from 2 to 3. This is a triangle. It's going to be 1 times 3 divided by 2. So this area in here is going to be 1.5. So this is going to be plus, the displacement is going to be pi plus 1.5. So g of 3 works out to be 6.5 plus pi. Okay, so that's our g of 3 value. And we'll do the same for g of -2. G of -2 is going to be equal to start at 5 plus the displacement on the antiderivative of g prime from 0 to x is equal to -2. So this is under the g prime function. Now it's important to note that we are starting at 0, so our starting point is going to be at 0. But now we're integrating in the direction of right to left. So that means then when we get to -2, that's going to be this area here. Although the area is pi and above the x-axis, we know that areas above going backwards are going to be negative displacement. So that then becomes, this is going to be equal to 5, our original position, plus, now the displacement is going to be negative pi. So the y coordinate then at x is -2 is going to be 5 minus pi. For part B, it says find the x-coordinate for each point of inflection on the graph of y equals g of x on this interval. So inflections occur where the derivative changes direction, because where the derivative changes direction, we're going to have a change in slope of the derivative, which means we have a change in concavity on the second derivative. So we want to know where it changes direction. Well, the change in direction is going to occur here. We're going up, we're going to have a 0 slope, and we're going down. Okay, so that's 1 point. Okay, so at x equals 0, there's a change in direction, and that is a point of inflection. For this point here, going down and changing direction to going up, so at x equals 2, We have another change in slope on the derivative, which indicates a change in concavity on the second derivative. And again, at x equals 3, we're going up on this side of 3, down on this side of 3. So at x equals 3, we have another change in direction on the derivative, which indicates a change in concavity. So that is an inflection point. So we have 3 inflection points that we are looking for. In the last part, h is defined by this function. So we have this function h, which is a combination of g's and x's. So we're being asked to find the x-coordinate of each critical point h and classify them as min, max, or neither, min, max. So first thing is we need to find the derivative. If we find the derivative, then we can see where the derivatives are equal to 0, and we can look for critical points there. So the first thing is I'm going to differentiate h using the notation. So h prime of x is going to be equal to g prime minus the derivative of 1/2 x squared. It's just going to be x. So this is our value of our derivative. We need to see where this is equal to 0. Where is this h prime going to be equal to 0? Well, it's going to be equal to 0 where the g prime is equal to x, or where the y-coordinate on this graph is equal to the x-coordinate on the graph. Okay, so there are a couple places on this graph. Now, one way we can find this point is we can draw a line where y equals x, and where it crosses that line is where we're going to have x, the g prime, or the y-coordinate on this graph equal to the x-coordinate on this graph. And we can see that it happens at 3, 3, and there's also another point here on the circle. Okay, and since this is a radius 2 circle, we're going to have to work out that point. Okay, so I'm just going to start with my slope chart here. So we have at x equals 3, we have our h prime equal to 0. And we have another point on the circle, and since this is radius 2 circle, I'm just going to draw it over here. This is a radius 2 circle, and so the x-coordinate is going to be, in this case, is going to be 2 divided by root 2, or let me just write that in. So it's going to be 2 over square root 2, and this is going to be 2 over square root 2. Okay, so that's going to be my x and y coordinate. So my x coordinate is going to be 2 over square root 2. Okay, so that's when the x and y's are the same, and thus I'm going to have a solution to this g prime equals x equation. So that blue line that I've drawn is the solution to that equation. So at this point, we can just test the regions here to see if they're positive or negative. So if g prime is, if the graph of g prime is above the blue line, we know that it's going to be g prime minus x is going to be positive. So in this region in here, where the g prime graph is above the y equals x graph, we know that's going to be positive slope. So it's going to be pointing up here. Between pi over 2 and 3, the red graph is going to be below the blue line, which means that the g prime is less than the x value. And so if that's the case, g prime minus x is going to be negative. So it's going to be sloping down like this. And then on the other side of 3, the same thing. It's going to be negative still. So we're going to have negative there. Okay, so there's my slope chart. We can classify each critical point here. The critical point at x equals 2 over root 2, that is a local max. And the point at x equals 3, it is neither local min or max.